In our last class, we had a little preview of today's lesson. Lesson 4.7 is exponents and multiplication. When multiplying powers with the same base, you add the exponents. And I show it to you in several ways. We can write this expression with a multiplication symbol of some sort here, where I use this multiplication dot here, or I can put them in parentheses. If I have x to the fifth times x squared, I am going to show you in expanded form that we can take this, and just this shows you exactly how this property is developed. We have now x to the fifth, which is 1, 2, 3, 4, 5, times x to the second. So if I show it to you in expanded form, I see that there are 5 plus 2, which is 7. So when we're going to multiply powers with the same base, we'll add our exponents. Here's a couple more examples. I have m cubed times m squared. I'll simply take the exponents and add them. It becomes m to the fifth. In this next problem, I have two different variables, but remember, if the bases are the same, we can add exponents. So I have x to the fourth times x to the second, which will give me x to the sixth. And then I have y to the fifth times y to the third, add my exponents, and I get y to the eighth. In my next example, I'm going to put in some numbers as well. When I'm looking at bases, whether they're numerical or variable, we're going to keep the base and add exponents. 2 plus 3 is 5. I'll keep the base and add exponents. 4 plus 2 is 6. Since I have a number base here, I can multiply out 2 times 2 times 2 times 2 times 2, and that will give me 32 x to the sixth. And that's its simplest form. And the only thing we can do with this is evaluate if I give you the value of x. Our next problem has the same base 3, so we'll keep the base and add exponents. I put down this little reminder that we should remember that when we have any number or variable and there's no exponent, it's to the power of 1, because any base with the exponent of 1 is equal to the base itself. So I have technically a 1 here. So that's 1 plus 2 is 3. I have m to the fourth times m, 4 plus 1 is 5, and n squared times n to the fourth, 2 plus 4 is 6. Once again, I see a number base, 3 times 3 times 3, we get 27, m to the fifth times n to the sixth. And there you have, again, evaluated this expression. When I have bases that are different, these coefficients in this next example, I'll multiply the 4 times 3, because we multiply coefficients. That will give me 12. But when I see I have the bases the same, w to the fifth times w squared, I'll add my exponents. Just a few key rules to keep in mind when we're doing this. These are different bases, so I can just evaluate 2 times 2, which is 4, and I can evaluate 3 times 3, which is 9. What do I do with coefficients? I multiply them. 4 times 9 is 36. Onto my variables, I have m to the fifth times m to the third. 5 plus 3 is 8. So when we're multiplying, the key to this is if the bases are the same, you keep the base and add exponents. Now there's a second property, and that's called the power of a power. When I take a power, an expression that's raised to a power, and raise that to a power, it's telling me to take what's in this grouping of parentheses, which is in this case x squared, and multiply it by itself 3 times. If I went and expanded, as I did in my initial problem, I'll see that I have 6 x's. So the key to this is when we're raising a power to a power, we'll multiply our exponents. Here's 2 more examples. I believe we did these in class last time, but we'll try them again. I have y to the 4th raised to the 5th. Well, 4 times 5 is 20. In the next, I have m to the 3rd raised to the 6th power. 3 times 6 is 18. So together we have 2 basic rules or properties when it comes to multiplication with powers. When we're multiplied with the same base, we add exponents. If we're raising a power to a power, we multiply exponents. In our next class, we'll explore division rules. So I think that's basically our lesson for today.